Welcome to Deep Engineering's YouTube channel, where we bring you real-world insights from the engineers and authors shaping modern software. Today, we are speaking with Sam Keane, author of Clean Architecture with Python, published by Pact. Sam is a software engineering leader with over 25 years of experience. He is a polyglot developer who has used Python in everything from early-stage startups to large-scale systems at companies like AWS, Lululemon, and Nike. At Lululemon, he led the creation of the company's first cloud-native development team, setting foundational standards for distributed architecture. Currently, as a principal engineer at Pluralsight, Sam focuses on leveraging generative AI for software engineering enablement, building tools and systems that amplify developer productivity through intelligent automation. His work combines deep technical expertise with a passion for making AI accessible to engineering teams. Still very much deeply immersed in Python, Sam collaborates with AI to design modular, future-proof systems that balance innovation with architectural integrity. He's here with us today to talk about how clean architecture applies to real-world Python systems, from structuring APIs and isolating domain logic to refactoring legacy code and scaling across services. Thank you, Sam, for being here with us today. We're really glad to have you with us.
Well, I'm very glad to be here. Thanks, Divya, for that introduction. Really appreciate it.
Wonderful. So let's get started. And let's start by talking a little bit about your book itself. And I'd like to start by asking you, what motivated you to write Clean Architecture with Python? And why do you think Python as a language needs its own treatment of these ideas?
Sure. As you mentioned in the intro, I've been in development for quite some time and Python for a big portion of that. As for the topic, clean architecture has been around, Uncle Bob's book has been out for quite some time. I'd always seen that, though, in the context of our static languages, like, of course, Java and C#, those types. And I kind of saw that in a lot of communities in Python, we thought we didn't quite need that. It seemed overburdensome. So I wanted to kind of take an approach and see, can we take from clean architecture aspects of it that will help us maintain, larger Python code bases without trying to turn it into Java. So I knew there would be a lot of pushback for that. So definitely wanted to keep it Pythonic. For, why write a book? This is my first published book. I think during COVID, those couple of years, I had a lot of time. And so I got into doing YouTube tutorials for game development. And I really liked that content creation process. And so when the opportunity came up to write this book, I thought, yeah, that's kind of the next step. And so those kind of, again, always wanted to write a book. So those motivations just kind of aligned with some good timing.
Yeah, that's wonderful. Definitely one of the better uses of that downtime all of us had. So moving on to my second question. In your book, how do you, in a nutshell, explain clean architecture in Pythonic terms, especially to developers, who know the classic concepts, but perhaps struggle to apply them cleanly in real-world Python projects?
Yeah, and I think kind of returning a little bit to the previous answer, I think clean architecture aligns quite well with being Pythonic and sort of the ethos of the nature of Python. One of the core then features of Python is to be explicit versus implicit. So clean architecture, again, gives you that sort of that map for your application. It's sort of like, you can think of it as, if you're doing object-oriented development, the first things you get very concerned with are the classes, how to design those classes. I'm sure we'll talk about solid. So you use those solid principles on that class itself to be sure it's cohesive. Clean kind of takes that and expands on it. And it's like, okay, how do we apply some of these same principles to the entire application as a whole? And it gives you that map. And the author of the original clean architecture was very explicit in saying that It's not a framework. It's not a rigid set of rules. It's more about a set of principles to follow and adapt to your needs. I'm sure we'll get into a little bit of there's not, one playbook for
Hmm.
clean. It depends on what you're building. You don't want to build a skyscraper if it's a little cottage code base that you have.
Right, right. And yes, actually, my next question was about solid principles. And so we are now going to move into the next section of our interview where we're going to talk a little bit about core principles and Python specific design. So solid principles are often cited as foundational to clean architecture. According to you, which of them are easiest and which of them is the hardest to apply in a dynamic language like Python?
Sure. I think it's kind of the usual suspects. So solid, there's some like single responsibility principle. A lot of folks comprehend, it's the first letter, and a lot of people comprehend that pretty well. It's a class should have a single concern, those sorts of things. And so that translates pretty well into Python. The, the compiler is not going to help you a lot in that regard. It's more of a human design decision. I think it gets more into the nuance of dealing with interfaces for the part of solid having well structured and focused interfaces. That's where it gets a bit more into the nuance of
In,
um,
yeah, I think you're referring to interface segregation principle.
yeah, yes. So
Yeah. Yeah.
that's getting more into the nuance of ensuring that you're not depending on more than you need to. So your interfaces are well composed. For instance, you might have a vehicle class. You wouldn't want to have the engine be a part of the vehicle class because you may have gasoline cars, but also electric cars. And so if you've coupled that concept of an engine directly into the vehicle base class, you're going to end up with a class that has, say, a power level and fuel level in liters. And so you're going to have portions of that interface that don't make sense for all the base classes or for all the concrete classes that come from it. And another one would be Liscog's principles. So essentially ensuring that, and this is where the compiler would help you in static language. So ensuring that you have a base class and then you have classes implementing it. You want to ensure that none of those implementers sort of disrupt the class. So at any point in your code base where you're referring to that base class, you could insert one of the child classes and it would function fine. So ensuring those child classes sort of cooperate with the original interface and they're just extending it on and on. And so if there's issue with that, a compiler could catch that. Python, you don't have that. So that's where it's type hinting. I'm sure we'll talk more about that because that's core to the book. Type hinting can help. That kind of gives type hinting paired with MyPy kind of gives you a little bit of that concept of a compiler checking types. So that could be very helpful in Python. And then just unit testing in your systems is good. So the L and the I, but I think those are the tougher ones for a lot of languages.
Okay. And S is the easiest. Brilliant. So the next thing I want to talk about is how do you enforce the dependency rule in your project so that business logic stays free from, frameworks, ORMs, or infrastructure code?
Yeah, and I should have brought this up earlier. The dependency rule is really core to clean architecture. It's if you get that one thing, you're doing quite well. So conceptually, what it means is that clean architecture is built in layers. So you have the inner domain layer, and then you're moving out, and that's just core business objects, very few dependencies. And then you're out to an application layer, which is kind of orchestrating workflows, management of those entities. So like save task, complete task, these sorts of things would be in the application layer. And then out to there's 4 layers in total. The third one would be the interfaces layer. And that's doing translation. It should be a thin layer. Often you'll have a thing in there called a controller. A lot of people be familiar with. That's doing translation between this next layer, the frameworks or the drivers layer, and the inner business core, that application and domain layer. And again, that outer layer is your frameworks, and that's where all the volatility is. That's your SQL alchemy, your external dependencies that you don't have control over, that aren't, you're utilizing but aren't a part of your code base. So that's the 4 layers. Back to your question, how do you enforce the dependency rule? And that's saying that dependencies all face inward. So the domain layer shouldn't be aware of anything above it, and continuing, the application layer shouldn't be aware of anything above it. They should only be aware of what's in. So again, in Python, you would still have this in other languages. So how do you ensure that something in domain layer is not depending on something external? You can do that through a static analysis. So you enable to depend, you're going to see those import statements in that class. So if you're in your task domain entity and you see it importing something from Django or Fast API, you've broken that rule. So it's part of it's pragmatic, but then you can get precise in enforcing this rule. So pragmatic is just ensuring the team understands the principle and why it's there. Getting a little more discrete is having literal folder structure in your code base. So a folder for domain objects, a folder for application objects continued. And so then the set of rules that any file in that folder is beholden to. And in the book, we give a simple example of it could be a unit test, a fitness function. So a test that runs and just checks, does linting on all the import statements, and it knows that directory structure of the layers. And so it can have a heuristic of, if I see, a use case in the application layer that's importing from, again, a driver or something like that, it can just fail the build. And again, you're shifting that knowledge of an issue left. And so developers can make that correction quickly. So that's kind of the hierarchy of just ensuring the team understands the principle and why it's done, having a discrete folder structure so it's easy to see, and then you can literally put in unit tests that kind of statically assert any violations in that regard.
Yeah. Okay. And I think something you mentioned, I think we're going to talk about framework invasion a bit later. But before that, I'd like to ask what kind of, I know you talked about it a little bit, but if I asked you to put it in best practices terms, what kind of project structure do you recommend? Do you prefer separation by layer, so domain interfaces, etc., or by feature? And how do you keep the layout from becoming overly rigid?
Sure. And again, we gave one example earlier of having a folder per layer. So that's definitely a possibility. But to get in front of this question, it's more about, from just a macroscopic, it's always have the simplest solution that meets the needs of your project and your team. So you may have, and we referred earlier about overbuilding, you may have a very simple CRUD application that's essentially an API fronting a database that's, has RESTful create, update, delete type functionality. There's not much to it. You could definitely build that in more of a feature structure. So it's the task microservice. So in that case, you may just go with the Fast API framework and have that 1 or 2 file implementation that makes sense for that, because there's not a lot of business domain logic in that particular service. So again, don't overbuild it. I see a lot of single file frameworks that work quite well. So that's probably the end of the spectrum of as simple as you could get. Then the other, you would start to as projects get larger, code bases get larger, and you have, not sure if I could think of an example, but something more complex than task that has a lot of business rules around it, these sorts of things. That's where you might want to start to shift out to that domain structure we talked about earlier. So it's a folder per layer. And ultimately, it's also putting in a structure that makes the right thing to do, the easiest thing to do. So if you have a literal domain folder, if you're in meetings and the team's decided, oh, we now need, you had task. And so now what's another thing we could have related to that? Well, say you used to be just a single user application, but now you're going to support multiple users. So now you have a user domain object. And you've had those discussions in team meetings that, yes, we need this domain object. With that design where you have folder per layer, it's kind of the map is there for you. It's okay, I'm going to put the business object in domain. How that object is orchestrated with business roles, I'm going to put in the application folder layer, and then again on up the stack. So yeah, it's not one size fits all, and it's something you can evolve into. And if you the and the book talks about this ADRs or architectural decision records. So, and again, back to this explicitity, if that's a word, if your team's made a choice to kind of bend a common practice because it meets the needs of the team, just document that in an ADR, and then it's a cognizant choice versus some accidental complexity that got into your application. So that'll help developers that come after yourself, or it will help yourself in 6 months when you may have forgotten why you did that.
Okay, so now let's move on to the next section of our interview, where we're going to talk a little bit about real-world implementation challenges. And so I'm going to start with domain-driven design, which is a big part of your approach, of course. And how do you model things like entities and value objects in idiomatic Python?
Yeah. So there we get, well, something to bring up at this point would be the use of what you see, and I'm not sure if I call it modern Python, but you see it quite popular, is the use of parts of the language called data classes. So they're a great way to model these domain objects. They get rid of a lot of the boilerplate. So it's very easy to comprehend a class that you're seeing because it's distilled down to its properties, attributes, and then of course the functions for that. So there's that, and then that gives you a mechanism. You can have, again, an entity has an identity, an ID field. So in the book, in the companion app, we implement a very thin base entity class that every entity extends. So a task or a user, all of these entities, they extend this entity class. And then that gives you a primary ID field. So kind of a reserve field for any of those entities. So anything up the stack, if it knows it's dealing with an entity, it knows that ID field is there and that it's universally unique. And then you also, in Python specifically, you would, in that entity class, you would implement the hash method and the equals method so that, again, you're in line with that concept of entity having an identity, and that you can change all the attributes of that class, but it'll always be the same person or same task. It's just its attributes are changing, getting mutated through the system. The opposite of that, not opposite, but the value object is another common domain object, and that's a little bit of the inverse. It's doesn't have an ID field, but it's defined by its properties solely. So there again, you can use a data class and you can set frozen equal to true. And so that makes it an immutable class. So or immutable object, sorry. So in that case, that might be like an exchange rate, something that has, if any of its attributes change, it's not equal to what it used to be. So that's why you make it immutable. So you have that guarantee that you send this exchange rate out into the system, it's going to stay with its values and kind of adhere to that contract of being a value object. So to kind of wrap up, it's just, as a Python developer, you know that the tools to follow that domain-driven design are built into the language. So it aligns well with, again, as you mentioned, it's solid and domain-driven design are foundational to clean architecture.
Yeah, right. And now going back a little bit to what you were talking about earlier, frameworks like Fast API or Django can easily creep into core logic. How do you recommend engineers keep frameworks out of the domain and use case layers?
Um, Again, it just kind of builds on what we talked about. So deciding on the literal directory structure that makes sense for your project. So again, back to making the right thing to do, the easy thing to do. So that gives you context when you're looking at any classes in, say, the application layer. It gives you a context of what would be abnormal behavior for a class in that folder. So that's just kind of a high level. Otherwise, it's again knowledge of how to use the solid principles, how to have those patterns. So take databases, for instance. So that's a very common framework. So SQL Alchemy, maybe something like that. Knowing that that's a framework, you shouldn't see any reference to it in layers below that. So that's the one rule. And then there in solid, you're using the dependency inversion. So you would have a user class and a user needs to get saved to the database. So the anti-pattern would be that user class in the domain directory would have SQL Alchemy methods to save the database. So it would be directly coupled to that. And what you do instead is use what's called a repository pattern. And you just define an interface that has very simple methods like save user, get user, delete user. And so now your user domain object agrees to that contract. And then in the frameworks layer, you build a class that extends that user repository class and implements those methods in what's appropriate for SQL Alchemy. So then you don't have that direct coupling. You just have both those classes or both agreeing to that contract. So that's really the pattern across the board to keep those direct couplings to frameworks at any layer in the architecture.
Right. All right. Okay. Now, do you use Pydantic or data classes in your domain models, or do you restrict them to boundaries? How do you handle input validation and transformation cleanly?
Yeah, so that is actually interesting. When I was writing the book, I got into the mode of, I think I was being too strict with clean architecture. And again, I kind of drifted into treating it like a framework for some amount of time in some of the early drafts. And what I saw was the pattern that I detected was that I was doing property validation on, say, a task. in two different places. So I was having to do it in the interface layer and then also in the domain layer using different mechanisms. And so anytime that happens, it's kind of like your spidey sense goes off that you don't want to be duplicating that validation. So that got me to kind of think bigger about, again, the message of clean architecture being a set of principles versus a rigid framework. So then and again, the framework in question that I was using was called Pydantic, which is very popular in Python. I use it extensively. So, and it has very good validation and serialization methods on it. So you'll see in the book, I think, as we get into the building APIs with Clean, that was where, again, we kind of talked about these CRUD applications that don't maybe want to overbuild. So that's where we made the choice we as in myself, I made the choice that if I were in the real world building an application, I would probably make the calculated choice to allow Pydantic into the domain layer of this application for a couple of reasons. It's very mainstream. It's very well supported. And the second is it got rid of a lot of boilerplate and duplicated code in that particular application I was building. So that's, again, a calculated choice you can make when building. Again, just be transparent about it. Put it in, again, we talked about those architectural decision records or ADRs. So make it be a team choice that, we're going to make this compromise to reduce complexity. You always want to try to do that. So that's one example. You can find others. And again, just make it a team decision and have it be documented. So like we mentioned before, other developers or, again, yourself in 6 or 8 months, you remember, oh yeah, that's why we chose to have Pydantic appear in the domain layer.
Right, right. And Sam, what's your testing strategy for a clean architecture code base? You talked about unit testing and things like that a bit earlier, but where do unit integration and end-to-end tests fit within this concept, sort of?
Sure. I think very common with test approaches, Martin Fowler and others had popularized this. You want this test pyramid. So the base of that being unit tests, which just test individual functions. They're very quick. So that they're testing the behavior of a class kind of on its own. So you want a large amount of those because, again, they run quickly. And then up above that is integration tests. That's where it's like classes working together. In our clean architecture, that would be classes working across these layers. You're testing that. And then the very top, the thin, is the end-to-end tests where you actually boot up the infrastructure and test as kind of a real user against the application. And the reason for that design is that these end-to-end tests are slow and they're often very brittle because they're testing the interface, which changes quite a bit. So it's a maintenance burden to have a lot of those types of tests. But if you have a tightly coupled application, it's hard to implement that pyramid. A lot of times you end up with an ice cream cone, they call it. So because the unit tests are hard to write, you just, brute force it and write a bunch of end-to-end tests that test the application. But again, then they're very slow and brittle, and it's a maintenance burden. So Clean enables, again, for you to have that true pyramid because, again, we talked about the domain layer having no dependencies. You can easily write a unit test because you're not having to start up a database or be concerned about some network call that's going to happen because there's no framework dependencies in there. So that it truly enables you to write up that plethora of unit tests that run in milliseconds, and you start to get that And again, to some extent up into the use cases, the application layer, because you've used that dependency inversion and all of those use cases are coded against an interface versus a concrete class, a test can easily just insert a mock that implements the interface. And then you keep those tests very quick also. So again, that allows you to have all those lower level tests, give you great confidence in your application. And then you need those end-to-end tests for those kind of critical workflows, that final validation. So Clean really just it enables the true test pyramid, which is sought after.
Okay, got it. And what's your approach to refactoring legacy Python code? How do you introduce clean architecture there without overhauling everything at once?
Yeah, again, a lot of that chapter we have a chapter devoted to that. A lot of it is common practice, no matter what you're doing. It could be, it could be a Rust code base. So the common things are what you don't want to do is these big bang releases where you go off and rewrite the entire stack and then try to release it all at once. That hardly ever works because it takes so long. The requirements change and, the system you're rebuilding is changing. So you have to figure out how to kind of slice up the problem. And a metaphor, strangler-fig, is used often. It kind of sounds kind of odd, but it's it's a nature of a fig vine that grows up a tree and slowly engulfs it. So in this case, Clean helps you in this regard because you're going from a system that didn't have a map that's sort of chaotic, and you're going into a system that does have that map and allows you to build it with discrete components. So that allows you to take service A and split it off into a clean architecture. And like we just talked about, have a full test coverage on that, those sorts of things. So where to start is, again, start at the lower layers. So look at your legacy system and find all the parts that are in aggregate building the concept of a user. Get all of that domain logic, and then shift and build your true domain user in the clean architecture. And then using gateways and feature flags, start to get to the point where you can parallelize traffic to the old system and the new system and compare and see that you have parity in the state changes of user across the boards. And beyond like the domain objects, just look for those natural bounded, what to the best of your ability in a legacy code base, try to identify those bounded contexts, returning to domain driven design, and then to extract those into the domains and the set of use cases against that domain, that sort of thing. So the common advice, do everything you can to get from a big bang release, and then know that the clean architecture is going to give you that guidance of how to restructure.
All right. I have got some interesting ideas for a working title there. Go clean to avoid brittle ice cream cones and certain slow death strangler fixed.
Yeah. Yeah, there was some interesting metaphors in that.
No, good. Very interesting. And now the biggest question that everyone wants to know. I think, Sam, you're very well placed to answer this. How is AI changing the way we approach clean architecture?
Yeah, it's AI is the definition of disruptive, this generative AI wave we've come in. And it's really interesting because, again, we started the book a little over a year ago. And in AI years, that's forever ago. I think baby chat GPT-3 was coming out or something. And kind of, it was LLMs were just starting to be able to build Snake. Like that was the extent of what they could build. And then you look where we are now. So there's a couple of dimensions. So if you're thinking of AI as like a feature you would add to an application, so integrating an LLM to an application, nothing really changes. It's again, that's a driver, framework driver. So the knowledge of, say, like LangChain or Llama Index, really common frameworks, that's all going to stay in the outer layers. So same playbook, and then you're going to integrate that into down to your your pure domain objects. So that part of it, nothing changes. The other part is using AI to build with. So coding tools, these sorts of things. So it a couple of things there. It helps. We talked about writing tests. AIs are great at writing unit tests, so you can definitely leverage it there. And again, and that's where you get out of sort of this hallucination issue with AIs. It's you're writing tests to validate, so you can know that the AI is doing the right thing. So kind of that's what some might think as like a boilerplate of building an application, writing those tests or implementing. The other thing we talked about is we have that user who needs to be saved to a database, so it has an interface contract. You can use AI to build the concrete class against that interface, at least get a start on it. So, and again, some people might think of that as boilerplate, but that can do that. And then overall, the advantage is that, and this term context engineering is coming up in AI, to where it's the realization that the AI's ability to help you is only as good as the context you give it. So if think about if you let it index these legacy tightly coupled systems, it's not really sure what the plan was. There kind of wasn't one. So the AI is going to continue to build against that code base without much of a plan. Whereas if you're explicit about your approach and you have, these 4 folders with easily defined rationale of why, what goes into each folder, all that context, that's going to the LLM just as it's helping a human. So using clean and having that playbook of how to build out your application is going to help those AIs do the right thing and not go off the rails. So it's exciting.
Yeah, yeah, that's exciting. It's working exactly within that space, isn't it? Um, so now we're moving into the final section of our interview, and we'll talk a little bit about scaling microservices and strategic design. So I want to start by asking you, how do you apply clean architecture across multiple services or modules? Should each follow the full layering pattern, or do you recommend something else?
Yeah, we touched on this a little bit. Again, it's not one pattern to fit everything. So with multiple services, kind of the same thing. I think again, it's the purpose of, and again, this is under the context that what you're building is multiple services. So you may, again, we talked about this earlier, you may have portions that are just really straightforward CRUD applications. You just know that you don't want to have direct database access, so you want to have an API in front of that. And maybe at this point in time, it's kind of one-to-one mapping. You just have it there for kind of a defense if you need to change that in the future. So those, fast API and using Pydantic throughout might be the right mechanism. So, but again, your larger or business rule-centric orchestrating parts of the application, that's again where you invest in a fully layered approach to those applications. And you treat even though you've built the services, you treat them as uh, framework drivers. So you have service A you've built, and you have service B you built. Service B treats service A as a detail and doesn't let um, its implementation details get pulled into the deeper layers of that application.
Okay. Now, when building scalable applications, how do you decide what belongs in the core versus what stays at the edge, for example, pagination, caching, or authentication?
Yeah, so that, again, there's a little bit of thought process to that, of course. So you kind of get into that domain-driven design mentality of what's core to the domain. So a user, what's core to a user. And there's versus like transport protocols and these sorts of things. Those are just sort of details. And the trick you can kind of use is that what makes sense even if you weren't a computer program. So to kind of explain that is that, a user having a schedule, that's a concept that makes sense even before computers were invented. So, but then you can kind of use that for things like the knowledge that we're transmitting using JSON or gRPC. That's a computer concept. So it's a detail of the platform we're implementing these user domain objects on. So, you know, to be facetious, if we switch to quantum computers in 10 years, we'll bring our domain objects with us, but all those other details are going to change. So that's, kind of the macroscopic way to think about it is what is core to the nouns, the objects of our system versus what's a transport detail, technology detail that's not core to that. And just keep that at the edge. And then there is some nuance to like authentication. That's more about you may have a system that needs to be impenetrable. So every layer may need to validate the authentication, have like a zero trust. But again, you may not be in that case. So you may stop authentication at, say, the adapters layer, and then everything below assumes authentication, or it doesn't have knowledge of authentication. So that's an example where that computer concept could come all the way down to the domain out of need.
Okay. And now we have reached the end almost, and this is my last question. How do you manage inter-service communication in Python systems built with clean architecture?
That's again, that's a the answer to that is kind of some common practices regardless, but again, clean helps you with that. So in where you have these messages going, often like an event-driven architecture, the messages, it's another way that you can leak implementation details. So be very cognizant of the information you're putting in the message. And again, you should be all past tense about this happened, these sorts of things, practices. So an example would be, I don't know if I can think of an example off the top of my head, but
All right.
yeah, overall, it's just be cognizant that that's a common way that, again, I just kind of repeating myself, but that those implementation details can get transmitted across the wire versus, a leaky interface or something at the code layer. So even at the transport level, you can leak implementation details that you don't want to. And that'll cause coupling also.
All right. Okay. That brings us to the end of this interview. It was a great conversation, Sam. Thank you so much for joining us and sharing your valuable experience and deep expertise with us.
Well, thank you very
Um,
much, Sibia.
Brilliant. And to our viewers watching, thank you for being here with us. And if you'd like to dive deeper into the topics we discussed in this interview, do check out Sam's book, Clean Architecture with Python. It's filled with real-world examples and practical techniques to help you build scalable and maintainable Python systems. You'll find the link in the description below. Until next time, this is Divya for Deep Engineering.